Through innovation and technology, Active Treatment Systems provides water treatment solutions to protect the environment from pollution, damage, and any endangered species from possible extinction. Travis Air Force Base is located in Fairfield, California, east of the San Francisco Bay Area. The base was constructed in June of 1942, and with its proximity to rail, highway, and water transportation, the War Department assigned the new facility to the Air Transport Command. By the end of World War II, Travis had become the West Coast's largest aerial port, airlifting troops and supplies to occupied Japan and Korea. In 1992, Travis came under the control of the newly established Air Mobility Command, providing global airlift and refueling support for humanitarian and military needs on a worldwide basis. In recent years, in order to support the volume of fuel used and transported through Travis, a new jet fuel tank farm was planned and developed by Kinder Morgan, consisting of 3 large tanks with the capability to store over 30 million gallons of jet fuel. Throughout construction of the tank farm, Active Treatment Systems provided safeguards to prevent any contaminated water caused by the construction of the tanks, hydrostatic testing, and stormwater runoff from polluting the environment. Based on the site surface area and stormwater volume of expected rainfall, an active treatment system was designed to treat 550 gallons per minute of stormwater. The objective was to keep all stormwater on site and to treat it until it was clean enough to discharge. Turbidity levels needed to average less than 10 NTU, eliminating concerns about violations or fines. At Travis, the main fuel tank area is enclosed within a set of levees, installed to provide long-term protection from fuel leaks and short-term stormwater contamination due to the construction process. The water collected within the levee system was pumped to a pre-treatment series of tanks, where polymer was added to enable the initial settlement and clarification process. Stormwater quality can change rapidly depending on site conditions. The quantity of polymer used was based on bench scale tests performed periodically to maximize efficiency. The tank volumes, shapes, and configurations were designed to minimize the water flow velocity and to maximize contact time. If the clarified water from pre-treatment was at 200 NTU or lower, and the pH was in the 6.5 to 8.5 range, it would pass through to the sand filtration step. A filter aid of polymer was added just before the sand filter at a rate of about 10% of the pre-treatment dose. Computer-monitored water quality instruments and automated valves either directed the water back to the pre-treatment tank for additional treatment or directly to discharge to the environment. Active Treatment Systems' knowledge of stormwater contamination and system design for the process of water treatment was a vital element to the successful completion of a project of this scale. All ATS operators are specially certified for this work. The ATS goal for all of its projects is to keep the water being treated from causing damage to the environment and to protect their customers from fines resulting from an out-of-spec discharge.